In this video, we're going to look at graphing with the vertex form of a quadratic function. So as you can see here, we've got an example, and my function is f of x equals 2, parentheses x plus 1 squared minus 2. The first thing we want to do is identify our vertex. So in this case, we're going to look at the h and the k. Now, h is always the opposite sign of what's inside the parentheses. In this case, h is going to be negative 1 because there's a positive on one side, so it's opposite of that. K is exactly what's out there. So in this case, I have a negative 2, so K is going to be negative 2. Now your vertex is always H, comma, K. So in this case, my vertex is negative 1, comma, negative 2. So what I'm going to do is I'm going to go over here. I'm going to draw a couple lines down my graph here. And that was a really, really poor line. So I'm going to draw the lines down here. There, so this way we can actually do our graph. So the first one I want to point graph is my negative 1, negative 2. So I'm going to go over 1 and down 2. So that's that point right there. Now I need to come up with some points. So we're going to identify coordinates on the left and the right side. So my vertex was at negative 1. So on the left side I'm going to do negative 2 and negative 3. And on the right side I'm going to do 0 and 1. So what we're going to do is take each of those numbers and plug them in. So my first one I'm going to plug in is negative 3. So I do 2, negative 3 plus 1. Squared minus 2. So we do the order of operations. I'm going to do inside first. So I do 2, and then this is going to become negative 2 squared minus 2. What's negative 2 squared? That's positive 4. So I have 2 times 4 minus 2. 2 times 4 is 8. Minus 2 is going to give me a 6. So I put a 6 there. I'm going to repeat that exact same process for the other three numbers. And I'm just going to fill those in to save time. So it'd be a 0, a 0, and a 6. Now, let me graph those points. So at negative 3, I'm going to go up to 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So it's right there. Negative 2, I'm at 0. 0, I'm at 0. And 1, I'm at 6. So I'm right up there. So then we would connect the dots. Now, when you connect your dots, just like any function, we go beyond the last points because I can keep going. So we're going to put little arrows there. So there's my parabola based on this information. Now, the next thing we want to look at is does this function have a minimum or a maximum? Now, if you look, it doesn't have a maximum because it keeps going on forever, but it does have a minimum. That minimum point right there is my vertex. So in this case, the graph opens upwards, so the function has a minimum. If it opened downwards, it would have a maximum because it would be a peak instead of a valley. The minimum in this case is my vertex. It's negative 1, negative 2. Next thing we want to look at is what's the axis of symmetry. Now the axis of symmetry, if you remember from the first example, is going to be a line that's going to go directly down the center of my graph through the vertex. So in this case, if I was going to draw a vertical line through my vertex, the line would be at x equals negative 1. Now notice the points on the other side. So here, if I go to the left on negative 1, negative 2 is 0, and the negative 3 is 6. If I go to the right from negative 1, I have the exact same values. That's what you should see. It should mirror across those two things. Now, in this case, next thing it wants to do is identify the zeros of the functions. The graph appears to cross the x-axis at points 0, 0, and negative 2, 0. Looks like it's going through those 2 points right there. So the zeros appear to be negative 2 and 0. It's those two values. Negative 2 is there, and 0 is there. Now, if we were going to want to look at these based on the function, when I plug those in, I get zeros out. And as you see the table right here, the answers for the zeros are always going to be 0. The values for the zeros will be the x values that you're plugging in.